Hello, I'm Cesar Herrera.
And my name is Luis Servicio, and we're currently seniors attending the University of Texas at El Paso, pursuing a degree in electrical engineering.
And today we will be going over Ethernet networks. During this presentation, we'll be going over the history of Ethernet networks and how they have changed over the years. We'll also be going over the basic principles that make it operate.
We'll also go over some pros and cons of the IEEE 802.3 standard, as well as some current applications regarding schools, hospitals, and job sites. And lastly, we'll go over the future of this standard.
So let's get started. The year was 1973. The United States was beginning to draw down its involvement in Vietnam. The films The Exorcist and George Lucas's American Graffiti are all the rage. And at Xerox's Palo Alto Research Center, Robert Metcalfe first came up with the idea of Ethernet networks. He was inspired after studying AloaNet, an early networking design developed by University of Hawaii. And in 1975, Xerox filed a patent application naming Robert, David Boggs, Chuck Thacker, and Butler Lamson as inventors. In 1979, Metcalfe started the company 3Com and convinced Digital Equipment Corporation, Xerox, and Intel to unite in promoting Ethernet as a standard. They called it the Digital Intel Xerox Standard, or DIX for short. It specified a 10 megabit per second Ethernet with 28-bit destination and source addresses and 16-bit Ethertype field. The standard was published in 1980 with version 2 coming out in 1982 and was formally standardized on June 23, 1983 with IEEE 802.3. Now initially, Ethernet had to compete with many proprietary protocols such as the Carrier Sense Multiple Access with Collision Detection Protocol, Token Ring Protocols, and Token Bus Network Protocol. So with all these protocols out there, why did Ethernet win out over all of them to become the standard we know today? Well, at first, Ethernet was able to use cheap coaxial cables, and then later cheap twisted paired cables like the ones we use today. Bob Metcalfe's company 3Com began selling adapters for various computers, including both Intel and Sun Microsystem computers. In fact, by 1985, 3Com had sold 100,000 Ethernet adapters for IBM PCs. This widespread use meant that Ethernet was a must-have feature by the beginning of the 90s, and some computers began to come with Ethernet ports and cards pre-installed. Now, as previously stated, the Ethernet standard originally used coaxial cables and has changed to use better and cheaper modes of communications over the years to the modern RJ45 cables we all know and love today. But so has how the computers communicate over the years. The original Ethernet worked by all computers on a network sharing a common coaxial cable to send and receive transmissions. This meant that any data sent would be received by all computers, even if they weren't the intended recipient. Furthermore, this shared medium meant that collisions of signals could occur, leading to data being corrupted. In order to rectify these problems, modern Ethernet networks use switches to send information to its destination. Ethernet operates in the data link layer and is considered a local area network, meaning that they are usually smaller networks controlled by a single organization and must connect to a central hub to send data to a larger network. This can be seen in most households where various smart devices are connected by Ethernet to a router. The devices are the stations and the router is the hub that routes all traffic to the destination device, or wider network we know as the Internet, if needed. The basic idea behind Ethernet is the sending of information through data packets. The 802.3 packets are comprised of a preamble, which is used to synchronize data transmissions and indicates the end of a header, a frame delimiter that signals the end of the preamble and start of the frames, thus allowing the receiver to determine the first bit we will cover in more detail in the next slide. And finally, the extension, which is only required when using gigabit half-duplex operations. Now, half-duplex operations just means that both computers are able to communicate with each other, but are only able to speak one at a time, sort of like walkie-talkies. Conversely, a full duplex operation would allow both systems to communicate simultaneously. Now, the reason the extension is added to 1 gigabit per second operations is because these packets travel fast and are sent fast, and the extension is there for the signal to meet the minimum carrier event duration needed for the network to work properly. Now back to the frame. The frame is the largest part of the packet and contains the information needed to send the data, as well as the data itself. At the beginning of the frame, we have the destination address. The destination address consists of 6 bytes of data and specifies where the message is supposed to go. The address can specify either a single physical address, a broadcast address, or a multicast address, such as the one in our example, which, fun fact, broadcasts to all stations on the LAN. Likewise, the source address is the same size and specifies where the packet is coming from, much like a return address on an envelope. Next, we have the length type field of the frame. The frame is 2 octets and can be one of 2 meanings depending on its numerical value. If the value is less than or equal to 1500, as seen in this example, the field indicates the byte length of the following MAC data client field. If the value is greater or equal to 1536, then the field will indicate the type of MAC client protocol. The MAC client data is the actual part of the packet that contains the information that is being sent. Its length is up to 1500 bytes, or 1504 bytes when it comes to Q-tag frames, or 1982 bytes for envelope frames. The pad is pretty much just filler to ensure that the frame is long enough for proper CD operations. And finally, we have the frame check status. All data sent is susceptible to errors from various sources, but the frame check status field notifies the destination whether the packet is corrupted. This is done by the receiver computing a running sum over the entire frame as it reads it. If that sum matches the magic number of hex value C704DD7B contained within the frame check status field, then the message was sent properly. If the sum total does not match the magic number, then the receiver will assume there was an error and discard the frame. Unfortunately, when it comes to Ethernet, there is no instruction specified to retransmit the frame.
Okay, let's go ahead and start with pros and cons. When I'll talk about several advantages when using this Ethernet cable. Number 1, it's going to be speed. Ethernet is just faster than wireless. The speed is from 100 megabits per second for fast Ethernet, which is also known as 100 base T, to 1000 megabits per second for gigabit Ethernet, which is also known as 1000 base T. And in the future, 10,000 megabits per second for 10,000 base T connections. Another perk of this is that wired Ethernet does not slow down the further from the router, unlike wireless connections. The second perk is going to be security. A major point when it comes to security is that there's no radio transmissions to intercept. In order to mess with this cable, you actually have to hack the router, switch, gateway itself, or access the wiring or switches physically in order to look at the packets or to mess with the cables on the network. The third point is that this cable is straightforward. Wired connections are easier to make, use, and maintain. In order to make an Ethernet cable, you just need 3 components: the unshielded twisted pair, or UTP as it's known, patch cable, the connector or terminal, and a crimping tool. It's that easy. With most modern computers, you can simply plug in the cable and you're done. Wireless connections require configuring the router and at least one extra step on the computer's side. You have to look for the network SSID and hope your password works. The fourth point is going to be reliability. Everybody who has used both a wired and wireless laptop knows how much likely the wireless option is to lose signal and speed as they walk around the house. With an Ethernet cable, you simply leave it there and there's no issues. Another reason that these are so used in industry is that they have a long lifespan. If you look up and behind a ceiling tile of your house or office complex, you'll most likely see an Ethernet cable that was installed a long time ago. For example, the College of Business Administration here at UTEP just celebrated its 50th birthday. And if you know where to look, some of the Ethernet cables around the college are around 10 years old, and some even more. I will now talk about several disadvantages when using an Ethernet cable. Number 1 is going to be the infrastructure requirements. You must have the correct wiring and equipment to make a test, produce,
and maintain cables. Also, you will need a port on a physical switch for each wireless device that you would like to connect to the network. The second point is going to be distance limitations. Each wire has a maximum length from the computer to the hub, switch, or router. This distance is approximately 100 meters, or 328 horizontal feet from all categories of Ethernet, UTP, and shielded twisted pair cables. This has to do with the cable internal resistance that degrades the signal over long distances. In order to fix this, you need to switch every 91 meters or 300 feet. Because of this, the user will experience network performance issues. A third point is going to be external interference. A fixable but not mostly known problem with the Ethernet cables is that they're susceptible to external interference. This could come from the fluorescent light, motors, running a cable parallel to the electrical cables, and similar items that shed electrical or magnetic interference. Now we'll go with applications. Ethernet cables are everywhere we go. The majority of times they're behind a wall, on top of a ceiling, and sometimes on the floor under tiles. The following are some locations in which cables contribute to our everyday life. Number one is going to be home. The best known issue of these cables are to connect desktop computers and or gaming systems to a modem. They also connect a Wi-Fi router to a modem, and lastly, they're used to connect your smart TV, smart speaker, and even your smart refrigerator to a network. Second point is going to be office. Desktop computers are more prevalent in offices and schools. All of these are connected to a central router via an Ethernet cable. Some examples of these are computer labs in schools, which sometimes contain upwards of 45 computers. In office spaces, you could imagine a room full of cubicles. On each cubicle, there's a computer using this cable. Lastly, hospitals. These cables are used to connect medical equipment, refrigeration for medicine and organs, and life-sustaining medicine to central computers that monitor their every move. Last, future. The most recent category of the Ethernet cable is the Cat6, which supports a speed of 1000 megabits per second compared to the old Cat5, maxing at 100 megabits per second. In a few months from now, the new standard Cat7 will be launched, and it is thought to reach a speed of 10,000 megabits per second. That is 10 gigabits per second. You could download a whole 2 to 3 hour movie in 4K resolution in a few seconds with that speed. If we compare this with the newest Wi-Fi IEEE 802.3 standard, which reaches a max speed of 1000 megabits per second, that is 1 gigabit per second, the wireless standards falls behind. Today, the Ethernet cable is mostly used in industry to connect modems, routers, domains, and servers together, and it's rarely seen in homes. The IEEE 802.11 wireless standards are becoming the norm now that computers are smart and powerful enough to fit in a tablet form factor. In the future, we may see a world where every computer, phone, and smart device is connected wirelessly. But in the backstage, the Ethernet cable will reign supreme by connecting wireless access points, internet service providers, servers, data centers, and even whole continents together.
This concludes our presentation.
And thank you for watching. Have a nice day.
Why do I keep on looking at you? Damn it. And as soon as we're done, I look at you and I had to have the hardest time